Hello everyone. In the previous video we have seen one of the method of retrieving the original message signal from the received AM signal, that is one of the method of AM demodulation technique, that is the square law detector. In today's video we are going to see what is the drawback of using square law detector. So let us see what is the simple block diagram of a square law detector, as already we have discussed in the previous video. So the square law detector is having two devices. One is a square law device followed by the low pass filter. So here we have obtained the mathematical expression value of V2 in the previous video. Here the simply V2 is obtained by designing the low pass filter cutoff frequency FC as the frequency equal to the message signal frequency that is transmitted through the modulation technique. So from this equation we can derive the V2 expression finally as it is A2 AC square Ka square m square of t by 2 plus A2 AC square Ka into m of t. Theoretically, this noise expression will be deleted. Why? Because the theoretical cutoff frequency is always equal to the message signal frequency. But practically, the cutoff frequency FM, which is approximately equal to sum of the multiple frequencies of FM. That is, we can say that FM, 2FM, 3FM, 4FM frequencies are partially transmitted or partially retrieved. Okay, so we cannot eliminate these partial frequencies through the practical designing of low pass filter. So in order to eliminate this noise, we have to maintain certain conditions. And now what are the conditions we have to maintain in order to recover the only signal frequency, that is FM, we can see below. So here if you observe from the expression V2, we can define the ratio of S by N, that is signal to noise ratio. If you see, it is A2 AC square Ka m of t by A2 AC square Ka square m square of t by 2. Now if you consider or if you do simply mathematical equation, finally we can get 2 by Ka into m of t. Now assume what is the value of m of t. I can assume the single tone message signal that is transmitted. So I can write the value as m of t is equal to am cos 2 pi fmt, whereas we know that the Ka value is equal to 1 by AC. Okay, so if we substitute that, then it is 2 by Ka is 1 by AC, so I can write as AM by AC, which is nothing but the modulation index value. So 2 by M into cos 2 pi fmt. If I can take the signal to noise ratio as the maximum value, that I can write as maximum value, then I can get it is equal to 2 by M into maximum of cos 2 pi fmt. So maximum of cos 2 pi fmt value is 1, which implies that S by N value is 2 by M. So in order to retrieve only the signal information, means if the signal strength should be high, then we can maintain the modulation index value should be low. But we know that if the modulation index is low, which in turn the efficiency will be low. If modulation index is low, the efficiency will be low, means most of the power that is transmitted, the AM signal is wasted. And it is also impossible to design a low frequency modulation index value in practical for transmitting the high frequency AM signals. But here, in order to maintain the signal value is high, the modulation index value should be low. It is practically impossible. That's why we cannot use this square law detector method in the practical applications where the modulation index value is high. Hence this method is not used. In order to overcome this, we can going for other method, that is envelope detector, and how we can recover the message signal from the envelope detector we can see in the next video. Thank you for watching our video.